All right, students, we're going to go over some special factoring patterns, and this should complete then the different types of polynomial strategies that you need for factoring. And so I've listed them here. You might want to jot these down in your notes. The sum of two cubes, the difference of two cubes, and factoring by grouping. If you'll write down the format there, I've given you two examples, and I was going to talk through how to use each one of these special factoring patterns. The first thing that you have to be able to do is to be able to tell which factoring pattern you need to use. And so the first two are very similar, the sum and the difference. And it's going to be two terms where you've got a cubed root. Usually at least one of them will have a cubed root, such as this one that's in red, x cubed plus 8. Okay, it's going to have something that has a cube in it. That's how you know that it's not a square, a perfect square. It's a perfect cube. And then the difference between the plus and minus will just be whichever. If it's a plus, then you go with the sum. If it's a minus, you go with the difference. Hopefully that makes sense. Factoring by grouping, you choose this one when you have four terms. And I'll go over that in just a moment. Okay, let me explain each of these three examples. Here's example 1, the x cubed plus 8. Okay, so that matches the pattern of u cubed plus v cubed. It's u cubed plus v cubed is just a pattern. It's saying if you have a term that's cubed plus another term that's cubed, this is the way it's going to be laid out. So the very first step that you have to do is take the problem that you're given and make sure that both terms are written as perfect cubes. So we already had x cubed. That was already written that way. And then remember, you can write 8 as a power of 2. 2 to the third power would be 8. So we just rewrite our problem like this, where both terms are raised to the third power. Then what you need to understand is because the x is first, wherever you see a u, you're going to write x. And for this problem, wherever you see a v, you're going to write 2. So then it just becomes a matter of substitution into the format. So notice it said u plus v, so I wrote x plus 2. X plus 2. We just replaced the x for the u and the 2 for the v. That's the first binomial parentheses. Then the second is a trinomial polynomial, and it is supposed to be u squared. So since x was in the place now of u, you write x squared. Then it says minus u times v. So we're going to multiply the 2x and 2 and the x together. Just write it as minus 2x. And then it says plus v squared. So because 2 was in the place of the v, we square the 2 and it becomes 4. So our final answer for factoring, quantity x plus 2 times x squared minus 2x plus 4. Okay, when it's a difference of two cubes, notice this problem, x cubed minus 125. Okay, that one's a difference. So now we're going to follow the other pattern. By the way, if you'll notice, the two are very similar. Very similar. And so that's why this pattern is so wonderful. Because as long as you know which one is a sum and which one's a difference, you just plug it into the pattern. So it's really the same thing. X cubed minus 125, we would write it as x cubed minus 5 to the third power. Wherever there is a u, you're going to write x. Wherever there's a v, you're going to write 5. Plug it into the difference pattern, and it would be x minus 5 times the trinomial x squared plus 5x plus 25. So check that out. Make sure that makes sense as to how that whole pattern is factored. Just makes it a lot easier. Otherwise, it's kind of like, how would you even know that two terms become a binomial times a trinomial? The last method is called factoring by grouping, and you can follow through here. The first step that you do is you put parentheses around the first two terms and around the last two terms. The first two terms, then, you factor out the greatest common factor. Since they both had an x squared, you'll notice for x cubed and x squared, the greatest common factor there is x squared. Factor it out of the parentheses, and then divide both terms by x squared, and you're left with x plus 2 inside of the parentheses. Second parentheses was 3x plus 6. Bring the 3 out, and you're left with x plus 2. That is a good thing when you have the same parentheses in both of them. You factor out an x plus 2, and then take your x squared and your plus 3 and put those in a parentheses together. And that is called factor by grouping. I've got a number of examples to do, and so our homework problems. Okay, number 15 is you look at the problem, 9x squared minus 4. Well, that's not even a cube. And so 15, you should already know how to do this. This one is where you take the square root of 9x squared and write 3x and 3x. And then one's a plus and one's a minus, plus 2 and minus 2. So that's all you have to do when you have a difference of two perfect squares. Okay, now x cubed minus 8. Okay, that one is going to be what we are one of our new patterns. That's right here. And it's x minus 2, x squared plus 2x, and plus 4. That one's just like the one that we did in the example, but this time it's a difference. Okay, now number 19 is interesting because remember you need two numbers or two terms that are both raised to the third power. So 216x cubed actually will be written as 6x to the third power because 6 to the third power is 216, x to the third power is x cubed, but my u is going to be this whole term of 6x, and then 1 to the third power. So this time it is 6x plus 1, that's u plus v, and then u squared is going to be 6x. Notice the whole term of 6x is u. So you're going to go 36x squared, okay, then minus, because it's this middle term is minus in this pattern, minus u times v, so 6x times 1 would just be minus 6x, and then plus v squared, which would just be 1. And so there you have it. Number 21. Okay, this is the first one where you'll notice 200, x squared minus 50. 250 both have common terms, common factor there. So go ahead and factor out a 50 first, and it'll be 50 times 4x squared minus 1. Okay, factor out any common factor that all the terms have. Always factor that out first. And then we're going to be able to go 50, and this one is a difference of two perfect squares. So you're going to go 2x plus 1 and 2x minus 1. That's how you would do number 21. Okay, 23, same thing here. You're going to factor out and do 64x cubed minus 1. Factor out a 2 first. And then this one is a difference of two perfect cubes. So I'm going to do a 2 here. And then notice 64, you're going to be able to write 64x cubed as 4x quantity to the third power. 4x quantity to the third power will take you back to 64x cubed minus 1 cubed. Okay, I have to do that because I need the two bases right here and here. And it's going to be 2 times 4x minus 1. And then 4x squared will be 16x squared plus 4x plus 1. Same thing here with the 3. Factor out the 3 first. 3 goes into 81. Sorry, I don't even have my phone, so it's kind of late as I'm recording this. Let me make sure that I'm gonna do it correctly. 3, 2, 6. Okay, good. 27. Okay, 3x. 3 times the quantity x to the third power plus 27. Okay, then you can rewrite that as x cubed plus 3 to the third power, because we always want something with 3. And then 3x plus 3, x squared minus 3x plus 9. Okay, now let's try some factoring by grouping. Okay, so number 27 here, you're going to put parentheses around the first two terms and the second two terms. And then remember, you're going to factor whatever's this common in each parentheses. So from this first one, I'm going to factor out x squared, and left with x plus 1 times x plus 1. The second parentheses didn't have anything to factor out, but I still need something in front. I still need a number in front, so I can combine those two together. Factor out the x plus 1, and you're left with x squared plus 1. Okay, the second one here, factoring by grouping, number 29. Again, the first two terms here, factor out an x squared. You're left with x plus 2. And then factor out a 5, x plus 2. You know you're doing factoring by grouping correctly when you get the same parentheses. So x plus 2, notice, is the same, so I'm going to factor that, put that one in front. I only need it once, because then I can combine the x squared and the plus 5. X squared plus 5. Okay, and then 31, same thing, parentheses. You start getting the swing of things here. 9 goes into both 9 and 18, and both of them have an x squared as a factor. So then when I factor out 9x squared from the first term, I'm just left with an x. From the second term, I'm left with a 2. Second parentheses, you should also factor out a 7. You're left with 7 times x plus 2. Last step, factor out your x plus 2 from both of them, and then combine 9x squared and plus 7. Okay, that's number 31. Okay, now on 33, notice you check all your terms. You got 4 terms here, 2x cubed, 4x squared, 4x, and 8. Okay, and so you're going to factor out a 2 first. X cubed plus 2x squared plus 2x plus 4. And then factor 2, then we're going to go x cubed plus 2x squared, and then plus 2x plus 4. Alright, and right here, 2x squared x plus 2. Okay, and this, really this one is out front. Okay, this one out here, well, that's what we factored out initially. Okay, then we go x plus 2 times x squared plus 2. Alright, and that's what you're going to continue doing for 35 and 37. Just always put the first two together and then factor, and then 37, 39, 41, 43, 45. I'll finish up those for tomorrow.